Just give me 1 second. Okay, let's go ahead and play this. All right, how's that look for everyone? Is that all right? Can you see the first slide on my presentation?
Yes, we are able to see it.
Okay, cool. So I'll go ahead and get started then. And let me just start my clock so I know how long I've been talking at you guys for. I want to make sure I can stick to time for you. Okay, cool. Well, hello everyone, and thank you for coming to this DevOps Online conference today. My name is Gabe Hollenby. I'm a technical evangelist for Amazon Web Services, and I'm dialing in from Singapore, where I live. So technical evangelist may be a title that you're not familiar with. All it means is I'm a software engineer, a developer by trade, but I spend most of my time not just writing software, but also discussing with other software developers about what they're building, how they're building it, and learning what problems they're facing so that I can take that feedback back to AWS, and also so that I can share the best practices that AWS is building with the rest of the world. And that's what I'm here today to share with you. So let's get on with the show. Here's my agenda for what I hope to cover in the next 30 minutes or so. Depending on how quickly I go, it might be faster or slower. We've got, first I'll cover what I think DevOps is, what it means to me, and what AWS-enabled DevOps looks like. Next, I'll talk about AWS CodeStar, which is one of my favorite services that we have at Amazon Web Services, and I'll tell you why. And then we'll go into a bit more detail about it and how it relates to a bunch of the different code services that fit in under the AWS code services umbrella, like code pipeline, code build, etc. We'll actually do, I hope, 1 or 2 live demos, depending on how the demo gods are. Hopefully they'll be with us today. And how time goes, but I hope that I can show you some, and then we'll wrap up with a summary at the end. So let's start with what is DevOps. Well, hopefully this is not too big of a question for anyone on this call, but just in case you're new to the DevOps community or to this term, to me, it means literally the union of people who do development and people who traditionally do operations. So building the software and getting the software out in a production environment and making sure it stays healthy. Those used to be very separate teams, but in the DevOps philosophy, there's no silos at all. In fact, often they're not even, we don't just say there's no silos, often it's the same team, right? The developers and operations blend together into a team that is holistically responsible for making sure that we have successful development and deployment. And of course, the end goal is to get software out in front of our customers more quickly and more reliably, and to do that as quickly as possible, not just the first release, but as many releases as possible with as short of a loop cycle as we can, because every time we get new working software in front of our customers, we'll learn more about how we can continue to make it better, right? Software is never done. And that's the end goal, is, of course, happy customers. And this is what I think the release process looks like. It's 4 main stages. First, we have the source code stage where we're writing our code. It could be Java files, but of course it could be anything else. I just picked Java as an extension here. Maybe this is also where you would do some peer review for new code that was being written. Or maybe if you like pair programming like I do, this would be the time when you could be doing your pair programming as well. Then after code gets checked in, we need to build it holistically, not just the units we were working on. And so that's where we'll compile if we're doing a compilation, a language that needs to be compiled. We'll run all of our unit tests, not just the code we were working on. This is where we'll also do things like style checking, perhaps some static analysis if your language or tooling supports that. If you're into containers for deployment, this is where you'll create your container images. We can summarize this by saying, here's where we're running some of the tests and ultimately building the artifact for deployment that we're concerned with. And then we'll get it tested as this thing we're working on relates to other things. Perhaps there's multiple systems or services involved. If you're working in a microservices style, or even, I don't even like the term microservices because it's too fuzzy these days, but we can just say many services situation where what you're building is only part of some whole. You want to do your integration testing This is also maybe a good time where if you've made any significant changes, you might want to do some load tests or UI tests, or even penetration testing, depending on your release workflow. And we could also think of this as the point where what we're doing is our UAT, our user acceptance testing. And ideally, this should be done in an environment that looks as close to production as possible, but of course, it should not be our production environment. And then after everything looks good, everybody's thumbed up everything, we go ahead and we get that deployed to our production environments. And ideally, all of this, or as much of this as possible, should be automated, even the releasing to production. Now, that brings us to the topics about CI and CD, and there's two kinds of CD, and I'll talk about both of them for a minute. So CI is, of course, continuous integration, and that's really the concept of making sure that every time we are checking in our code, it's going into some sort of central place where our automated builds and tests are run against it. So hopefully, we're writing tests for all the software that we're building. You don't have to do TDD, test-driven development, where you write the test first. I often do it that way, but you don't have to. But the important thing is, and I feel pretty strongly about this, you should have tests. And I'm not going to be a stickler and say you have to have 100% test coverage. But of course, you should have automated tests. They're immensely valuable, and that's what's going to give you the confidence to go forth and chase the golden dream of being able to do continuous delivery as well. Of course, the goals of CI are to find and address bugs quickly. So if we didn't do CI and I fixed some bug on Monday, I checked it in, I went on my merry way, and I did some different task on Tuesday and some other task on Wednesday. Maybe I was even on vacation Thursday for some reason, and Friday we do our deployments. Well, hey, you should never do deployments on Friday as a special event unless it's automated. But let's pretend in this case that we were, and we discover a bug. Maybe we're not deploying to production, but this is, Fridays are when we integrate all of our changes and push them out to our UAT environment. This would be really bad because when we find some bugs in UAT, it's been days since I finished the code that I thought I wrote correctly, and my brain has moved on to other things, and I forgot about how to fix whatever I was writing on Monday. Right? I flushed my short-term cache in my brain. So with CI, I'm writing code and committing it and pushing it many times a day, ideally, and I'm getting very immediate feedback on how my code is integrating with other units and other systems, ideally every time I'm pushing. And of course, the goal of this is to make our software better and to release software more quickly. That brings us to continuous delivery. And continuous delivery, the goal here is getting software out to the end users, or I shouldn't say the end users, I should say this is your UAT. Getting your code ready for UAT as quickly as possible. So after your code passes your automated continuous integration tests, it should get automatically deployed to a production-like environment or a testing environment, whatever you want to call it, where your UAT is going to happen, right? And maybe your other integration-style tests or pen tests that I was talking about before. The goal of this is to make sure that deployment to your production-like environment is a non-issue, right? You don't even have to think about it because it's already automated. You don't have to worry about messing anything up. The scripts take care of themselves. They behave the same way every time. And this is where if there are going to be any new deployment issues that crop up, we're going to catch it here first. And so we can learn about it and solve those problems and make sure we have smooth, automated deliveries to this production-like or UAT environment before we're ready to get it out to prod. And of course, the other kind of CD, continuous delivery, would be continuous deployment. And I have these three little lines here about it, right? So continuous integration only gets us this far. Continuous delivery gets us this far, right? It can get us all the way out to production, except there's like this gate. And usually this is somebody doing the UAT and saying, okay, it all looks good to me, or a team, or however you want. There's some sort of manual process where before the code gets all the way out to prod, someone has to say, yeah, I bless this release. But of course, continuous deployment is this goal of being so confident in all of your automated tests during your unit and your integration and your system testing and everything that you feel so comfortable that if everything passes, the deployment goes out. And maybe this doesn't catch everything. So to do continuous deployment well, you also need to feel confident that you can roll back any changes from production to a previously released version with confidence and with reliability. So that's sort of our level setting. So hopefully we're all on the same page. And now I can switch gears for a bit and talk about what this looks like in the AWS landscape. What do we have to offer when it comes to CI and CD and stuff? So it all falls under there are code series of services. And you could look at it kind of as follows. CodeStar is sort of the umbrella one that makes it easy to get started with all of the other services that you see on this slide. So I'll talk about them in a different order. Well, code typically starts with code commit. That's our Git management service. So if you don't want to use GitHub, but you want to run your own Git server on the AWS cloud, you can use code commit. Then code build is our build service. So this is I'll talk about this in more detail later, but code build is a scalable build service. You could think of it like, I used to use Jenkins back in the day, and I'd have a master node and have a bunch of worker nodes. AWS code build is like your worker nodes. They're automatically going to spin up it's a master too, in the sense that it will look and see when changes need to get built, and it will spin up a container that will run each one of your builds independently and in parallel. So it's extremely scalable. Code deploy is going to take your builds after they get built and make sure that they get out to the environment that they need to go out to. And it knows how to deploy following different strategies for different types of AWS services and tooling. And code pipeline is the service that brings all of those together and orchestrates the activities from commit to build to deploy. And CodeStar makes all of this very, very turnkey easy. So you can have these best practices set up from the get-go for new projects that you start. And so that's really what I want to talk more about. This slide visualizes this a little bit better. I didn't want to start with this one first because I thought it was a little too complicated. I wanted to make sure I at least defined each of the services. But what you can see here is CodeStar kind of covers all of this stuff. Code commit is the source phase. Code build takes care of the building. The testing phase, not only can you use code build for running tests that you've written yourself, but there's a whole suite of different automated third-party tooling systems you might like to use and services, and CodeStar supports many of them. And code pipeline, like I said, it orchestrates the steps together, and finally code deploy gets it out into production for you. So let's talk a bit more about CodeStar, because this is a service that, as I'm out in the developer community and I'm talking with lots of different software engineers, I ask them, do you know about CodeStar? And so much of the time, the answer is no, I haven't heard of it. What is this CodeStar? So I think it's great, and I wanted to get in front of you guys to share it with you today. I shouldn't say you guys and you girls, anyone who's on the call. So the goal of CodeStar, of course, is to make us set up with DevOps best practices out of the get-go immediately. It'll set up a really nice continuous delivery toolchain in minutes, right? So that holy grail we were after before. It also offers nice, secure collaboration for your team. Actually, there's a typo on the slide. It should say collaborate securely with your entire team, not just with your entire. I'm sorry, that's my fault. But you can manage your team access. You can add team members, and you can grant them different roles. We have integrated issue tracking and project management using Jira. I believe that we also have a plugin for GitHub issues if you prefer using that. And it makes it easy to develop on AWS in minutes. And again, I hope to be able to demo this for you in a little bit. And there's support for many different programming languages and different types of projects. So yeah, it's the goal is to make it really easy to set up and also deploy. There's over 20 different CodeStar templates. And I mentioned before, there are different ways CodeStar can set up your project to be deployed. Now, you might be a shop that likes to deploy directly on EC2. Well, we can do that with code deploy. But maybe you're using Elastic Beanstalk because you want something that's more fully managed when it comes to web application hosting and scalability. That's fine. Code deploy can sync up easily with Elastic Beanstalk. Or maybe you're like me. I'm really into serverless. I'm a big fan of things like Lambda and other managed services, so I don't have to worry about servers running. And of course, as you would expect, CodeStar can also set us up in a really nice fashion for serverless projects. I mentioned there are a lot of project templates. We support many popular programming languages, including C# and Go and Java, JavaScript, Python, Ruby, PHP. And there's many different IDEs that we support with plugins. Or if you don't use an IDE or you don't want to use any plugins, at the end of the day, your entry point into CodeStar from a code perspective, it's just a Git repository. So if you're comfortable working with Git from the command line or from any Git GUI tool that you're using, you can use CodeStar to get your code in and out. So let me see if I can demo creating a project for you guys. So I'm going to have to stop sharing and reshare because I want to share a different window. So hopefully this will work. Let's see. Bear with me. Let me just log into my AWS console here first. You guys don't need to watch me do that. That's boring. So 1 second. Just doing things like typing in my two-factor authentication. Okay, cool. So let me go ahead and share my web browser screen with you now. So share, and I just gotta find Chrome on here. I think it's this one. Let's see. Yep, great. Okay. Hopefully you guys can see I've got a Chrome browser screen sharing now. Somebody let me know if you don't see this. Otherwise, I'm going to assume everything's cool and keep going. Okay. So I'm going to go ahead and try and create a new project. Yesterday, I made a demo project because, if the demo gods aren't with me today, I still want to be able to show stuff off to you. So let's make a new project. Now here in CodeStar, when we make a new project, as I said, there's a lot of different applications and languages we can use. So for example, everything from a web application written in Go to a Java Spring web service running on EC2, to a Express.js web service running on EC2 or ASP.NET. Doesn't matter. For the sake of this demo, I'm going to say I want to make a web app, and I want to do it with Node.js, and I like Lambda for serverless. So that filters down my options, and I'll pick this project template. I will call this DevOps Online. And I'm going to say that, yes, I would like to use code commit for storing my Git repo instead of GitHub. And then I'll just say next. And here's CodeStar telling me everything it's going to set up for me out of the box. So code commit for handling my source, code build for doing my build and test phase, CloudFormation for doing my deploy, because this uses AWS Lambda. And so it's going to provision new Lambda deployments of my artifact using AWS CloudFormation, which is our infrastructure as code service that we have. And finally, for monitoring my application, since that's an important part of DevOps too, to make sure everything's healthy, we'll use CloudWatch, which is where all of our application metrics will go. So I'm going to go ahead and say create project. And hopefully, it'll set things up. Now, the next question I have to pick is, how do I want to edit my code? For the sake of this demo, I'm also going to try and show off Cloud9. This is our cloud-based, cloud-native editor that works right in your browser. And I think it does a good job for demos. Now, Cloud9 needs to run on a EC2 instance, and CodeStar will even set that up for me. A T2 micro should be totally fine. That's our smallest instance type. So I don't need to make any other changes here. But one thing I like to show off is you can say, well, I'm not always editing my code, so I don't always want to be running the remote server that my Cloud9 instance is installed and running on. So I can say, pause the environment for me, shut it off after 30 minutes of inactivity. You can change that, but I like 30 minutes. That's a nice cost-saving setting that defaults to that. So now I've said, go ahead and start this up, and it's going to deploy some things. So we're going to come back to this in a minute, and I'll show you how I make a code change and how it gets deployed automatically. If in the meantime, we'll go back to my slides and just let this provision, because it's not so much fun to watch spinners spin around for a few minutes. So let's go back to my slides. Okay, so what we will see when everything is set up is a nice project dashboard, which is where we can coordinate our day-to-day development activities. It's got nice things like a real-time view into our application activity for any metrics that the app wants to emit. We've also got the recent code commits listed there, so we can see what code is changing. The dashboard is customizable. We can add and remove different tiles. Comes with a lightweight wiki, which is good. It's a nice way to foster collaboration. And there's a number of extensions you can also use to add tile or functionality to your dashboard as well. So a little bit more about working with teams, because obviously part of setting up a nice CI and CD DevOps practice is having good team coordination and teamwork. So CodeStar thinks about this in terms of projects, and a project has an owner who can basically do anything they want to that project. You're adding and removing team members. You've got contributors, which are people who can read and write code, and also change things about the dashboard. And you've got viewers, and those are people who maybe are on a different team or perhaps less technical and don't want the ability to go in and mess anything up. They just want to look at it. So that's your read-only role. And you can have your same user account can be a member of different teams and have different types of permissions on each team that you're a member of. So that security is really nice too. You don't have to remember a bunch of different usernames. CodeStar will manage all of that for you and keep your permissions appropriate for each different project that you're working on. So if somebody has commit rights, they don't need commit rights for everything across all your projects. So again, we'll go ahead and we'll make some code to code commit. Code build will deploy it for us. There's a bunch of third-party tooling, different things. There's API, BlazeMeter, Ghost Inspector, a bunch of different testing tools and services that you might want to use that can integrate nicely into CodeStar. And then, of course, for deployment, CodeStar has the capability of using different techniques to deploy to different production targets, whether it's EC2 or an on-premises deploy, or going to coordinate with Route 53 and EC2 for Elastic Beanstalk. We've got you covered. So that's what it looks like and how CodeStar sets it up with Code Pipeline out of the box for us. And finally, I forgot to mention, so let me put this in here too, we can deploy to Lambda or API Gateway as well. So let's go ahead and try and demo a continuous delivery interaction now. So hopefully my project is done being spun up. It usually only takes about 1 or 2 minutes, but again, I didn't want to sit here and have everybody watch what I was doing since it wasn't really ready yet. So I'm going to stop the screen share here and switch back to my other window. Okay. So you can see here, I've got a desktop, a dashboard all set up, and my IDE and my project are ready to use. So I can dismiss this notice. And if I'm first new to CodeStar, there's a video I can watch, and I can set up teams and configure issue tracking. I'm going to close that right now because that's not super exciting for my demo. But what we can see here is there's a tile here for a wiki, and I can do things like edit the wiki. You can see there's a commit history here, and we can see that CodeStar made an initial commit for me when it made the demo project creation. And it's already gone through the process of noticing that the first bit of source code was checked into Git, and it's being built right now. And it looks like the build just finished. And so now it's in the process of figuring out what does it need to do to get this deployed automatically for me into a production environment. And once it's all ready, after this first deploy finishes, there will be an endpoint here that I can click on, and I can see exactly what that looks like. So I've gone a little bit fast in this case. It's not entirely ready for me to show you the first part of it. But what I'll do is I'll go ahead and I'll prep the first change I want to make. But before we actually commit that change, I'll show you what it looks like from that first deployment. And then we'll see that I've made my change, and hopefully we'll see it then get automatically deployed. So let's go ahead and edit this code. And to do that, I'm just going to use the sidebar here and pop open this Cloud9 IDE that I told it to provision for me. And because Cloud9 is an editor that works right in the browser, it makes it really easy to collaborate with other people. You can do pair programming really well with this. It supports multiple users editing the same files at the same time with different cursors and things like that. So it makes it easy to share your editing session with others. And what we can see here is the first time I launched this IDE, it went in right here, if you look at the very bottom of the screen, and it's cloning my repository for me. And because this is basically a fresh EC2 instance, like a virtual server for us, the first time we use it, we have to we want to tell Git who we are. So I'll just say my name is Gabe Hollenby, and I will write my email address in as well. I'm just going to say gabe@example.com here. And we should be good to go. And now you can see here on the left-hand side, this is what my source tree looks like from the demo project I created. And I know that what I want to do is, well, first let me show you the tests, right? Because I told you automated tests are important. So this is a pretty simple automated test here. You can see all it's going to do is it's going to get our index page, and it's going to make sure that the status code of the attempt to get that web page was 200. And it's going to make sure that the body of our HTML response contains the word congratulations. And it'll also make sure that we have a content type response header of text/HTML. So if I don't update this test and I change the word congratulations out of my index page, the test won't pass. So I have to make sure to either leave congratulations on the page somewhere, or I need to change my test too. For this case, I don't think I want to show a breaking test, so I'll leave congratulations alone when I go to edit the page. I'm quickly just going to come back here and see if the application is ready to be deployed. Yeah, it looks like the deploy happened. So before I make my change now, let's see what it looks like already. So this is our first deployment that came out of the box when I started the project, and it says, congratulations, you just created a Node.js web application. So let's go change this. I'll leave congratulations alone, but we'll change what appears below it. And that'll just be our demo code change so we can see our CI and CD happen. So I know that to make that change, because I've looked at this demo repository before, I just need to come here and edit this index.html file. And I'm going to just change this second line here, this H2, and I'll just say, welcome to DevOps Online. And if I save that, all I need to do is make a commit now. So I'll just make this bottom window a little bit bigger so you can follow along. And for those of you who are comfortable with Git, I have to change into the right directory. Inside the DevOps Online directory, I'm in Git. I can say Git status, and I can see that I've changed that one file. So I will add that file to my staging area. I will make my commit, and I'll say, changed my welcome message. And we'll push that. And so the nice thing is you'll notice I didn't have to configure any keys or anything because I told CodeStar to set this up for me with Cloud9. It automatically provisioned keys appropriate to that Git repository for me. So that's nice. This Git repository is not open to the world, but this EC2 instance and this Cloud9 development environment just automatically got set up with the appropriate permissions and keys for me. So that change is pushed. So in a minute, we'll see that already. We've seen that a code change has happened. We can see here that it's in my commit history. And in a little bit, we'll start seeing some application activity come in here too. Now, just to make this graph here a little bit prettier, I will refresh this a few more times. Now, we don't expect to see this change yet because it hasn't run through our test and our deployment cycle. But I'm just going to refresh it a few times so we can see a few hits on the page in our graph. OK. And now, again, because we don't really want to watch a bunch of things spin, it's going to take a minute or two. So we'll come back and we'll look at this again at the end of my talk. And hopefully, we'll see that the deployment happened successfully. So back to the slides. And there we go. So I mentioned there's integrated issue tracking. So out of the box, if you use Jira we found to be a very popular issue tracking and project management software tool. You can use that. You can just log in and copy the Jira URL from your project and tell CodeStar, hey, here's my Jira URL, please integrate, and it will. It's very easy to get started. I don't have a Jira instance set up, so I'm not going to demo that for you guys today. But there's a lot of different partners and tooling out there that you might already be using that can integrate very nicely with CodeStar for all of your DevOps needs. So these are just some of the ones that are available to you. I wanted to put some of the more popular ones out there. So if you were thinking, oh, I have to use only AWS stuff, that's absolutely not true. There's a lot out there. One that I want to call out specifically, because I talked before about how I used to use Jenkins. And one of the things that I really didn't like was that I would have a certain number of worker nodes in my Jenkins setup. And oftentimes I would have builds waiting to run, but all of my worker nodes were busy. And I didn't like that. And I felt like managing my Jenkins worker cluster was kind of a pain. What CodeBuild's main selling point is for me is the fact that every build, it doesn't need to wait. It can spin up and start running immediately in parallel. And that just scales out automatically for you. So that's just awesome. You don't need to wait for your builds anymore. And the other thing is, you're only paying for the time that your builds are happening, getting executed. So if you have worker nodes and in your classic Jenkins setup, they're sitting around some of the time, maybe not doing anything at all, right? Possibly at the end of the day when your developers go home for the day. But with CodeBuild, you're only paying for the time that code's actually being built. So it's actually quite cost effective as well. So to summarize, CodeStar gives us improved collaboration out of the box with rapid delivery of software. in a reliable fashion because we're doing our automated tests and practicing a good CI/CD workflow. It's secure and has nice permission management for teams. The scaling will happen automatically, and it's quite easy to get up to speed, and the builds will happen very quickly as well. We don't need to wait. So with that, let me go and check and see how our deploy went. So let's switch back to Chrome. There we go. And we can see the deploy is happening right now. This might actually be a little bit stale. I found that the dashboard can lag a little bit behind. So let me just refresh our example page and see what this looks like. No, it's still actually deploying. So hopefully in the next minute or so, we'll see that this change comes through. I have a thank you slide out in the back, but I don't want to go to it just yet. I want to give this just another few seconds because I'm coming up right on 30 minutes just now. So if you don't mind, give me another 30 seconds. We'll see if this deploy finishes. If not, what I'll do in the meantime is I will also just go back to another CodeStar dashboard that I have, or CodeStar project rather, my demo one I made yesterday, and I'll show you here that it actually went through and did a deploy successfully. I can show you what the deploy history looks like. So if you pull up code deploy, we can see here that it went ahead and it figured out exactly the changes I needed to make, and it deployed them successfully. A nice thing to show, actually, while I'm waiting, is perhaps the build history as well. So let me pop this open because I told you I didn't want to show you a failing test. I actually made one with a failing test yesterday. So you can see here, this is the first build that happened at 5:52 yesterday. And then I had a failed build when I changed something. And if you have failed builds, it's actually very easy to see why. So you can look at that build history, that build run. We can see that my pre-build failed. That's where it would actually run our automated tests. In the build logs, and I can see that there's my test failure right there. And it actually showed me the relevant parts already. It was telling me that there was a string assertion where I was expecting a particular HTML body to contain congratulations, but it didn't because I removed congratulations from my original test when I ran this. So then I went and I fixed my test by changing the test, and then I had a successful build. Okay, enough talking. Let's see if my deployment actually finished. And look, it did, so that's great. Congratulations, welcome to DevOps Online. And if we go back here, we can see in my dashboard that it deployed successfully just a few seconds ago. And so as time goes on, we would continue to see our application usage history here too. So this is updating in real time as well. And that's it. Let me go back and just share my thank you slide with you guys. So thank you so much. I went just a little bit over time. I hope that's okay. 2 minutes over. I beg your forgiveness. Thank you so much for letting me share this with you. I had a lot of fun, and I would love to keep in touch with all of you. The best way to reach out to me if you have any questions or want to follow up is on Twitter. My handle is Gabe Hollenby. It's just my first and last name smushed together. So with that, I'll say thanks, and I don't think we have any time for questions. So if you have questions, please just follow up with me after the fact online. Thank you.
Thanks, Gab. Really, it was a great session with a demo. Thank you for that.
It's my pleasure.
Yeah, as Gab mentioned, if you have any questions, you can send out a mail to him, or you can catch him in the Twitter.
Yep, thank you very much.
Thanks, Gab. And it's almost 4 hours continuous learning. I know people all over the world join this conference, and there are 2 locations where corporate people join, one in Belgium and another one in Singapore. Thank you for your presence. I know people from home, they have the flexibility to have food, breakfast or lunch, dinner from home, and you can listen to it. And the people in Belgium, I know already people have a breakfast, it is served, and in Singapore they already had the lunch. So now, having said that, let us go to the last session. Last session is from Koti. He is from United Health, and he is going to talk about do DevOps or die.
Yes, thank you, Maris.
The
Hey,
floor
good
is yours,
morning.
Koti.
Yeah, can you hear me, Maris?
Yes, Koti, I'm able to hear you.
Okay, great. So good morning and good afternoon and good evening, based on where you are from the world, which part of the world I'm not sure, but welcome, and it's very difficult to be a last speaker as usual. Hopefully, I will be talking about some other dimensions of the DevOps. While all of you have understood various aspects from technical aspect to the deployments on CA, CD, and so on and so forth, I will be talking